Welcome. In this video, I'd like to give you a brief introduction to the Data Conservancy packaging specification. But first, I need to give you a very high-level overview of the Data Conservancy architecture. With that background, I'll then spend a few minutes talking about a new external component of that architecture, followed by a brief description of what we are calling the packaging specification, a model used by that component that defines how to organize data into packages to allow efficient ingest into the Data Conservancy system. Here is a very high-level schematic depicting the architecture of the Data Conservancy system. You have probably seen it before, perhaps as early as the DCS alpha release in 2011. As you can see, the DCS is a layered system where the layers are meant to be quite decoupled with HTTP APIs between them. This allows for a partitioning of the data preservation problem into separate parts, what is commonly known as a separation of concerns. The lowest layer is the Data Conservancy Service, or DCS, and is the component that deals with archive and preservation services. It is the archive, if you need to use that term. The archive also knows about the relationships between various entities in its model. It knows nothing about the business layer. The next layer up is the business layer. It knows about higher-level objects such as projects, collections, and data items, and the functions that people might want to perform on those sorts of items. Functions like creating a new project, assigning people to be members of that project, creating collections within that project, and including a certain set of files as members of that collection. On top of that is what is called the reference user interface. Although the Data Conservancy team has developed a limited user interface, the expectation is that most institutions and organizations using DCS will want to develop or use their own interfaces in conjunction with the DCS. However, we recognize that it is important to have an example of how to do that. And it is also true that the Johns Hopkins University Data Management Service needs a user interface, so the reference UI was built to fulfill those purposes. Some of the key reasons for this type of partitioned architecture is because the Data Conservancy wants to be able to support data from a wide variety of disciplines and needs to be able to evolve over time. The goal is that any of these layers, or actually any component within any of these layers, should be able to be swapped out and replaced by a different component or newer system at any time. With that brief overview, let's talk about some new components being added to the architecture with the DCS Beta 1.1.0 release. These are the first components in what we are calling DCS Lite, a data management tool suite to be used by researchers while they are conducting their research to organize their data prior to ingest into a repository. These new components are called the packaging tools. They allow a user who has many files, perhaps a whole directory tree full of data files to ingest, to spend a little bit of time up front defining, perhaps programmatically, how the data should be organized when it is ingested into a repository such as the Data Conservancy, and then allowing that repository to automatically ingest that entire directory tree all at once. No manually entering information about individual files one at a time. The package generator is a standalone component that could be installed and run anywhere, even on a system that isn't connected to a Data Conservancy instance or even the internet. For example, I could see generating data packages while still in the field during a field campaign, say while you are organizing your thoughts and data at the end of the day. An internet connection to a Data Conservancy instance or other repository is needed only when you are ready to deposit a package. Creation and/or deposit of a data package need not happen right away, perhaps not until after the data has been shared amongst your project team, cleaned up, validated, analyzed, and journal papers written. You might even want to hold off until after consultation with a data management specialist at the repository you are working with, just to make sure that you've met all the requirements for data to be deposited. The point is that you have control over when and where data packages are created. So what do packages look like? Well, I'll show you a depiction of the specification on the next slide, but basically, for our reference specification, we are reusing and combining two very standard technologies to create this first type of Data Conservancy package. The first specification is BAGIT, a hierarchical file packaging format widely used and well understood within the digital library community. The other is the Open Archives Initiative, Object Reuse and Exchange Specification, or OAI-ORE for short, a semantics-based mechanism for expressing the relationships between collections of objects. When provided with no other instructions and pointed at the top of a directory tree, the package generator can automatically create a package. When it does, it assumes that the top-level directory represents a project. Any lower-level directories are collections and subcollections within that project, and that files are data items within the collection corresponding to the directory within which it was found. In other words, that the directory structure directly reflects the business objects, if you remember that term, within the repository where the data will be deposited. Only if these assumptions are not adequate does a user have to go in and update or add relationships to the default set generated. As promised, here is a depiction of the structure of the ORE-OAI part of the packaging specification, mostly for the truly hardcore techies amongst you. Basically, all it says is that packages may contain many objects, which could be projects, collections, data items, pointers to items out on the web, and/or files. That files can be metadata for any of these objects, that projects can contain collections and data items, that collections can contain other collections and data items, and that data items may contain files or web resources, some of which may be metadata for other data items, collections, or projects in the package. Given this, let's take a quick look at a real example from the ELOKA project. These are the contents of the Santa Kaluwak project from the ELOKA program. The top-level Santa Kaluwak folder isn't shown here, but is what the packaging tool would be pointed to. As you can see, left to its own devices, the package generator would create 3 top-level collections, one each for the Johnessy EPAC, Luckasy Takatak, and Peter Katuk directories. Also attached to the project would be 2 files containing maps. Similarly, the Johnessy EPAC collection, by default, would contain 2 maps and 2 subcollections, one titled EPAC Interview and the other EPAC Sea Ice Narration. If instead you wanted the EPAC interview to be considered a single data item and not a collection, which in this case it would be since the sole reason for splitting the interview into 4 parts was to create smaller files, the person generating the package would have to override these defaults and indicate that the EPAC interview directory should be treated as a data item and not a collection. If that were done, the results might look like the following, which uses the SMIL 30 specification to indicate that the interviews are all part of the same data item and should be played in a specific order. I note that while the Data Conservancy comes with a limited set of relationships that it understands, it can store any sort of semantic relationship extension such as this one. Over time, we anticipate that popular extensions will become understood and used by the DCS system itself. In the meantime, storage and retrieval of these relationships is possible, but use of the relationships, for example to control playing of these sound files, would need to be done by whatever system is accessing the data. In summary, the new packaging tools added to the Data Conservancy system as part of the Beta 1.1.0 release allows users to configure and deposit entire directory trees of data into the Data Conservancy. If the default packaging rules are sufficient to meet your needs, you do not need to do anything else except submit your package once generated. However, if you have more sophisticated needs, the package can be updated accordingly. This can even include adding additional semantics that the Data Conservancy doesn't yet understand, but is capable of storing and retrieving. Packages, once created, can be automatically ingested. In fact, if you are routinely and automatically acquiring data, it might be best to have your programmer script automatic creation and deposit of your data packages. Thank you for taking the time to view this video on the Data Conservancy packaging specification. For more information on the Data Conservancy, please visit our website at www.dataconservancy.org.